Okay, so the question we did in class, let's make a few things clear first. So if we have the sine curve, we know that the sine curve looks like this from 0 to 2 pi. We know that the cos curve looks like this from 0 to 2 pi, and we know that the tan curve looks like this from 0 to 2 pi. Right, now, for a function to have an inverse, okay, it must be 1 to 1 and be defined at all points. Okay, so let's have a look at our graphs. Sine, for example, I've got sine, the value 0 and 0, they're the same. Half and a half, they're the same. Minus a half and minus a half, they're the same. So this is 1 to many. So, I mean many to 1. So that goes to the same value, that goes to the same value. So this is many to 1. But I can't, that means I can't have an inverse. Okay, the same for cos and for tan. So what we do is restrict the domain to make sure that no value is repeated. So if I've got my sine curve, what I do is I restrict that from like this, and I say that we can only go from pi over 2 to minus pi over 2, and you can see that no point is repeated, no value is repeated. For cos, I go from 0 to pi, and you can see that I can't go from minus pi over 2 to pi over 2 like sine, because what would happen, this part of my curve would have repeated values. So, and then the last one, when I'm doing tan, I just have one single continuous curve, which means it's between pi over 2 and minus pi over 2. Okay, so they're the restricted domains that we work with. Now, let's go to our question. It says that arc cos of x, from the left-hand side, arc cos of x is equal to arc sine of the square root of 1 minus x squared. Right, so let's start from here. So our arc cos of x is equal to something, we'll call it y. Now, if I take the inverses of that, that means that x is equal to cos of y. Remember we said before that if f of x is equal to y, then x is equal to the inverse of y. All we're doing is swapping our domain and range. Okay, right, so now we've got that x is equal to cos y. We'll use our favourite identity, that cos squared of y plus sine squared of y equals 1. So then what I can do, I can say that sine of y is equal to plus or minus the square root of 1 minus cos squared of y. And we already defined cos of y as x. So that means we can say that sine of y is equal to plus or minus the square root of 1 minus x squared. Okay, now, as we know that the range is from 0, as we know basically that x is between 0 and 1, and we know that sine of y is greater than 0, that means that it must be between 0 and pi over 2, because that's where our curve is positive. So that means that sine of y can't be equal to minus root 1 minus x squared, because that would be a negative number. So now that means we know that sine of y is equal to the square root of 1 minus x squared. So now all we have to do is take the inverses of both sides. So I'm going to take an inverse of this, arc sine of, oh sorry, I should do this the other way around. It means basically that our y is equal to arc sine of the square root of 1 minus x squared. And now we have two things that are both equal to y, so therefore arc cos of x is equal to arc sine of the square root of 1 minus x squared, as they're both equal to y. Right, now part B. So it says give a reason why this result is not true for x between -1 and 0. So we know that arc cos of x is only defined between pi and pi over 2. Okay, so that's basically where arc cos is equal between 0. You remember basically if we draw this, we know that it looks like that. So when it's minus, that's going to be between pi over 2 and pi. Okay, so that's basically, we know that's true. But arc sine is only defined between pi over 2 and minus pi over 2 and pi over 2. So that means that arc cos cannot be equal to arc sine when x is between -1 and 0. Okay, I hope that's cleared things up.